I'm going to be talking about derivatives and integrals with respect to the exponential function. Okay? Let me start by analyzing the derivative of a to the x, where a is some positive number. Okay? Now, to analyze that derivative, we can start with the equivalent expression, the equivalent limit expression for that derivative. Now we can write a to the x plus h as a to the x times a to the h. Okay, and now we can factor out a to the x from in the numerator. And finally, we can pull out the a to the x because it's not dependent on h. Okay, now that is not a limit with a simple answer for an arbitrary positive value of a. However, I'd like you to do an exercise with me. I'd like you to analyze that limit. I'd like you to approximate that limit with your calculator for a few values of a. Okay, for example, you could a fast approximation to that limit with respect to a equal to 2 by calculating this. 2 raised to the 0.0001 minus 1 all over 0.0001. Okay? So essentially pick a small value, okay, replace h with that small value, and then evaluate that expression. Okay? You will get various values for different choices of a. What I'd like you to do is I'd like you to find a value for a for which the limit approximations get very close to 1. All right? So find the value of a that makes the limit get really close to 1. Okay, you might want to pause the video and do that now. All right, I hope you noticed that that limit is approximately 1 for a equal to 2.71828. And you can even find more digits in the decimal expansion. Okay, that'll get it even closer to 1. Now, that decimal is a famous number. Okay, that's what's referred to as the natural base. Okay, that's called e. Okay, so apparently the derivative of a to the x is equal to a to the x when a is equal to e. Okay, in other words, the derivative of e to the x is equal to e to the x. It's only true for this specific value of a. Okay, that's an important result. All right, the derivative of the exponential function is the exponential function. Now, we can immediately see what the antiderivative of the exponential function is, right? The antiderivative of the exponential function is the exponential function plus a constant of integration. Okay, that's our second important result. Okay? Now, let's use these results to calculate some derivatives and integrals. So, what do you think the derivative of to the 5x is? Well, we have to use the chain rule, so we would get e to the 5x times the derivative of 5x, or 5e to the 5x. Okay? What about the derivative of e to the sine of x? Okay, well, using the chain rule again, e to the sine x times the derivative of the sine of x. Okay, and so there you go. All right. What about the integral of e to the x from 0 to 1? Okay, well, the antiderivative of e to the x is e to the x plus c. So we can find this definite integral by evaluating e to the x at 1 and at 0. So that gives e minus 1. Okay. What about the integral, the antiderivative of e to the 10x? All right. Well, we can use u substitution. We can let u equal to 10x. Then we know that the derivative of u with respect to x is equal to 10. So we can rewrite the original antiderivative problem as the antiderivative of e to the u times du all over 10. All right, so that gives for our answer 1/10 of e to the 10x plus c. All right, now I would like you to do some exercises. Would you please try to calculate the derivative of e raised to the square root of x and e raised to the reciprocal of x, the derivatives of those two functions. So pause the video and try to work those out now, please. All right, so using the chain rule, we have to multiply e to the root raised to the root x by the derivative of root x, which is 1 over 2 root x. So simplifying, we get e to the root x over 2 root x. Root x, e to the root x over 2x. I just removed the root x from the denominator, but that's not mandatory. Okay, so there's one way to express the answer, and then the other exercise, we would get e to the 1 over x times the derivative of 1 over x. Okay, cleaning it up, minus e to the 1 over x all over x squared. Okay, and then finally, would you please do the integral from 0 to 1 of x times e to the x squared with respect to x? All right, pause the video and do that now, please. Okay, so I'll go ahead and do it as well. So I'm going to use u substitution with u equal to x squared. The derivative of u with respect to x is 2x. So the original problem can be expressed as the integral of e to the u du all over 2 with respect to the integral of that with respect from 0 to 1. All right, and that's equal to 1/2 of e to the u evaluated at the difference of what I get when I evaluate that at 1 and 0. So let's see, 1/2 of e minus 1/2 gives e minus 1 all over 2.